Welcome to day 5. We're going to be working with finding equations of exponential functions from some points on the graph. Packet page 12 and 13 will be your homework. And for the homework last night, you had to find the equation and tell the transformations. Now they wanted them all compared to either 2 to the x or 3 to the x. So remember, any of the ones with fractions, 1/2 is really 2 to the negative 1, so that's like you have a negative up in the x. So any of the fraction ones are going to have a y-axis reflection automatically. And then the 4 out front, you can either say vertical stretch by a factor of 4, or you can say multiply the y's by 4. So for the first couple, we will talk about the whole process, then we'll just check the answers and the transformations. So sub in your 2 points for the x's and y's, put the equation with the larger exponent on top, divide. We get 1/4. When you divide your b's, you subtract the exponent, so you get b squared. And when you take the square root, just take square root of top and bottom on its own. So square root of 1 is 1, square root of 2, square root of 4 is 2. Then sub that b back into one of the equations. If you have one that's raised to 0, sub it in there. That's a lot easier. You get 4. And if your b is a fraction, you have to have it in parentheses. So it's not a bad idea to just always put it in parentheses. This one, you could either say vertical stretch by a factor of 2 or multiply y's by 2, and then the minus out front is an x-axis reflection. One thing I want to point out in this one, when we divide and subtract our exponents, be really careful when the bottom thing's a negative. So we should have 0 minus a negative 1. So that becomes a plus, and that's how we get the b to the first. So negative 2 times 2 to the x. This one in our final equation, the negative 1's the only thing we got, so that's a reflection over the x-axis. Negative 2 times 1/2 to the x, we had reflection over the x-axis from the minus, and you could either say vertical stretch by a factor of 2 or multiply the y's by 2. We got 4 times 2 to the x, so you can either say multiply y's by 4 or vertical stretch by a factor of 4. Here's another one that when you divide the b's and subtract the exponents, be careful. 0 minus a negative 2 really becomes a plus 2, and then you take your square root to get your b. All right, this one's the first one that didn't have a 0 term. So when you sub in, negative 1's the larger thing. So when we divide, negative 1 minus a negative 2 gives us 1, so we just get that b is a half. Now this one was probably tricky to sub back in. So I did to the negative 1, 1. So that's 1 to the negative 1 and 2 to the negative 1. Those switch where they go in the fraction and become positive exponents. So now we have 2 times a. When you divide it over, you get a is 1/2. So our final equation, we had 1/2 times 1/2 to the x. The 1/2 in the parentheses, because it's like 2 to the negative 1, is a reflection over the y-axis. And you can either say multiply y's by 1/2 or a vertical compression by a factor of a half. In 7, we got negative 1/8 times a half to the x. When dividing, remember to do minus your minus, so you end up getting b squared. And when we sub the b as 1/2 back in, we've got to contend with the negative exponent, so it switches where it is in the fraction again. Now, this last step might have been tricky, dividing negative 1/4 by 2. Whenever you divide a fraction within a fraction, write it horizontally, do a keep, change, flip. So that's what we got right here. Negative 1/4 divided by 2 over 1. Change the multiplication and flip. And then when you multiply your fractions, multiply straight across, so we get negative 1/8 for out front. So we've got a reflection over the y because of the 1/2, reflection over the x because of the negative, and then you could either say vertical compression by a factor of 1/8, or you could say just multiply y's by 1/8. This next one, we didn't have to deal with negative exponents, so it was not quite as bad. We get 1/2 times 2 to the x, so you can either say vertical compression by a factor of a half, or you can say multiply the y's by a half. And that was it for the homework. So in today's lesson, we're going to be on page 10. Again, we're going to try and do these without a calculator. And we're going to make one thing harder today and one thing easier. So the thing that's harder is we might not be leveling off at the x-axis anymore. If you're leveling off at some other value, you've got to add or subtract that value on the end. So our general setup today is going to be a times b to the x, and then it'll be plus or minus some number. Sometimes that could still be 0 if it's leveling off at 0. But like in this first example, notice that dotted line where it's leveling off, that's called its asymptote, is at 2. So in this case, we're going to have a plus 2 on the end. Now the thing we're going to do to make the transition a little bit simpler today is we're going to look at all equations that only have 3 as the base. So every b value is going to be 3 today, and same thing for the homework. The b value is always going to be 3. And that'll simplify the transition a little bit to these new types. And then in tomorrow's video, we will see where we have to solve for b once again. So our base equation for this one is going to be a times 3 to the x plus 2. The 3 is because we're doing all 3 raised to the x's today. And the plus 2 is because that is where our asymptote is. That's where it is leveling off at positive 2. So the only thing we have to find is our value of a. So we've got an x and a y. We'll just sub that in. So we got 3 equals a times 3 to the 0 plus 2. So the difference when solving in this one is the first thing you will always do is add or subtract your value at the end over. So we've got to subtract that negative 2 over and we'll get 1. And then we're going to have a times, well, 3 to the 0 is just 1 because anything to the 0 is 1. A times 1 is a, so a equals 1. So when we write this out, we'll have 1 times 3 raised to the x plus 2. So the plus times 1 out front isn't doing anything, but the plus 2 at the end would represent a shift up 2. So the dotted line isn't drawn in here, but if we look and see where it looks like we're leveling off, it appears to be leveling off right here. So it's wherever it is flattening out the exponential function. So remember, we're using 3 as our b value today. So we're going to start off with a times 3 to the x. And then because we're leveling off at positive 1, we'll have a plus 1 on the end. Now we can pick either point to sub in. So maybe let's pick the 0, 0. So we'll put 0 in for y. We'll have a times 3 to the 0 plus 1. First thing we want to do is add or subtract over the value at the end. So we'll subtract the 1 over, and we get negative 1 equals a times anything raised to the 0 is just 1. So this will be a equals negative 1. So our equation now is negative 1 times 3 to the x plus 1. If this was one where we'd have to describe the transformations, the negative 1 out front causes a reflection over the x-axis, and the plus 1 on the end shifts us up 1. So this next one, we are leveling off at y equals 0. So we don't need to have anything added on the end. So we'll just have a times 3 to the x, because really it's got a plus 0 on the end. And we can sub in either point. I'm going to use the 2, 1, just because it's nice to have smaller numbers. So we'll put 1 in for y, and we'll put 2 in for x. So this, we didn't have anything to add or subtract over, so we'll do our exponent. 3 squared gives us 9. We can divide that 9 over, and we get 1/9 for a. So our equation is y equals 1/9 times 3 to the x. If we had to tell the transformations, we could either say multiply y's by 1/9, or we could say vertical compression by a factor of 1/9, because 1/9 is less than 1 and it's affecting the y's. If we go to the next page, page 11, this one is leveling off at 0. And we're still all day today and on the homework using 3 for our b value. So we'll just have a times 3 to the x, because that's really a times 3 to the x plus 0. And I'm going to avoid the negative, so I'm going to use the 118 as my point. So we'll have 18 for y and 1 for x. So this is 18 equals a times 3. We'll divide the 3 over, and we'll get 6 for a. So our equation will be y equals 6 times 3 to the x. If we had to tell our transformations, we could either say multiply y's by 6 or vertical stretch by a factor of 6. Number 5, let's look where we're leveling off. This one's leveling off at 0 again, just from the bottom side. So because of that and the fact we're using 3 as our b value all day today, we'll just have a times 3 to the x, because we're really adding 0 on the end. We can't avoid any negatives, so let's just stick with the 0 point then. So negative 4 is going in for y, and we'll have a times b to the 0. So negative 4 is equal to a times 1. Anything to the 0 is just 1. And a times 1 is a, so we get a is negative 4. So our equation is y equals negative 4 times 3 to the x. That's a dot, not a minus. And if we had to tell our transformations, we would have a reflection over the x-axis because of the minus out front. And then we could either say multiply y's by 4, or you can say vertical stretch by a factor of 4. And here's our last one for today. Notice we are leveling off at positive 3. So we'll have y equals a times 3 to the x plus 3. So the 3 and 3 to the x is just because we're doing that as our base all day today and on the homework. And the plus 3 on the end is because that's where we're leveling off. So let's avoid the negative exponent if possible. Let's go xy. So this would be 12 equals a times 3 to the first plus 3. Subtract the 3 over, because you always want to undo the plus or minus on the end first, and we'll get 9 equals a times 3 to the first is just 3. If we divide by 3, we get a is 3. So when we write out our equation, we'll have 3 times 3 to the x plus 3. So a whole lot of 3's going on. If we had to tell our transformations, we would either say for the 3 out front, multiply y's by 3, or a vertical stretch by a factor of 3. And the plus 3 on the end is a shift up 3. Now I just want to show you briefly what would have happened if we had used the other point. So we had y equals a times 3 to the x plus 3. If we sub the 4 in for y, and the negative 1 in for x. we can subtract the 3 over, and we'll get 1 equals a times, well, 3 to the negative 1, a negative moves it to the opposite spot of the fraction, so that becomes 1/3. So this becomes 1 equals a times 1 gives us a, and then over 3. The opposite of dividing by 3 is multiplying by 3, so that would also give us the a equals 3. So you get to the same point, or to the same spot in the end, the a equals 3. It's just a little bit more challenging to get there with the negative exponent. So if you can avoid it, you probably want to avoid the negative exponent. Sometimes, though, you might not be able to avoid it, and you'll have to work with it. So just remember the negative exponent moves to the bottom, or in other words, in general, to the opposite spot of the fraction. That's it for today's video. You've got the day 5 homework, and have a great rest of your day.